The overall goal of this procedure is to visualize leukocyte adhesion to the endothelium in harvested pressurized vessels. This is accomplished by first isolating a carotid artery from either a rat or mouse. Next, the vessel is mounted onto a pressurized chamber. The vessel is then pressurized and incubated for 1 hour at a desired pressure. Finally, labeled whole blood is perfused through the pressurized vessel. Ultimately, results can be obtained that show real-time adhesion of leukocytes to the endothelium through a customized ex vivo vessel chamber coupled to a pressure servo and a fluorescent microscope.
So the main advantage of this technique over existing methods like static adhesion assays is that leukocyte adhesion can be observed in intact functional arteries using whole blood.
This method can help answer key questions in the study of hypertension, such as the effect of high intraluminal pressure on inflammation and how it can contribute to atherosclerosis.
After isolating carotid arteries from 10-week-old Sprague Dolly rats and priming and pressurizing the perfusion chamber, mount the vessel under a dissecting microscope by first placing black polyester ties onto each cannula. Move the vessel to the bath, then mount 1/4 of the vessel onto the P1 cannula. Take care not to tear the vessel. Using a syringe filled with Krebs buffer, gently flush excess blood out of the vessel through the P1 transducer. Close off P1 to the chamber. With the polyester tie, secure the vessel to the P1 cannula. Move cannulas and cannula holders closer for mounting onto the P2 cannula. Mount the distal quarter end of the vessel onto the P2 cannula. Secure it with a polyester tie. To begin pressurizing the vessel, adjust the cannula holders to ensure no bend or stretch in the vessel. With P1 and P2 closed to the chamber, switch the pressure servo from automatic to manual. Check on the pressure servo to verify that there's no drop in pressure within 10 seconds.
So a decrease in pressure indicates a leak is present and the connections and transducer need to be secured in place to ensure they are pressure tight.
Adjust the pressure servo back to automatic, then open P2 to the chamber. Under the microscope, observe the vessel dilate when the tap is open to the chamber. Switch the pressure servo to manual. Again, check for any decreases in pressure. If a drop in pressure continues, then the system is not pressure tight and there's likely to be a hole in the vessel. Switch back to automatic and open P1 to the chamber. On the manual setting, check that the pressure remains stable. If stable, increase the dial to 2, which pressurizes the vessel to 40 mm of mercury. Switch to automatic and observe the vessel under the microscope. If necessary, adjust the cannula holder to ensure no bend in the vessel. On the manual setting, check for leaks. Then increase the dial in increments of 1, switching to automatic in between to observe the vessel under the microscope until the desired pressure is reached. Once the desired pressure is reached, move the chamber to the stereo microscope. Connect the temperature controller set to 37 degrees Celsius. Then, connect the peristaltic pump and aspirator to keep the Krebs buffer in the bath fresh. Incubate the pressurized vessel at 37 degrees Celsius for 1 hour. Check for leaks periodically. Label 7.5 milliliters of pre-collected whole blood with vibrant dye in the dark, then incubate for 10 minutes at 37 degrees Celsius. Collect the blood in a syringe, clearing any bubbles, and attach it onto a syringe pump with a heat jacket set at 37 degrees Celsius. Close off the P1 transducer to the chamber and connect the syringe and waste tubing. Purge the blood at 1000 microliters per minute through the waste tubing to remove any air bubbles. Open P1 to the chamber. The pressure servo will adjust automatically to maintain the desired pressure. perfuse the blood at 100 microliters per minute. Using a fluorescent microscope coupled to a digital camera, record 2 fields of the perfused vessel for 15 seconds at several time points. Representative images of leukocyte adhesion are shown here, where leukocytes are considered to be adherent to the endothelium if they remain stationary for 10 seconds. With video recordings on a continuous loop, cells can be counted as an average per field. While both low and high pressure will cause some amount of adhesion, a significant increase in leukocyte adhesion at the higher intraluminal pressure is observed. This is demonstrated quantitatively in this graph, where a greater number of cells per field adhered at 120 versus 80 mm of mercury of pressure.
Following this procedure, other methods such as PCR and immunohistochemistry can be performed in order to answer additional questions such as the gene and protein expression of adhesion molecules.